last session we were talking about arrays and the addresses, how the arrays do manage their address location, right? Why the first location index is 0, why the second location index is 1, that is what we have discussed. Is my voice is okay or it is low? Girls, those who are saying it's low, check out your audio settings of your system. Maybe you have put your audio on the low, your device audio system. Check whether you have set the audio bar to the highest volume. Okay, I'm getting many messages that the voice is good at their length. So I think the people who are getting low voice, please check your system. Okay. So let's continue. So what we were discussing in the sessions earlier. So till that point, whatever we have discussed, like till this particular point, what we have discussed is, let's say we are creating a box which is a kind of array. Let's say okay, this is the box, and let's say this box have 3 locations. In the first location, we are storing 1, 2, and 3. We call this as index 2. We call this as index 1, and we call this as index 0. Then it will be having address, let's say 0, 0, 0, 0, 0, 1, and 0, 0, 2. These are the addresses. Then what we have discussed in the last session is, let's assume that this array have name ARR. So what is stored in this ARR? So actually this ARR stores the start address of the array, which is 0, 0, 0. So when we print in the computer that I want to access ARR of 0, so how this line gets translates? This line gets translated like I am going to the location 0, and from the 0th location, I need to read the first element, right? Plus 0. So the reading of the first element starts. So this particular thing will read the first location. What if you are saying I am trying to access ARR of 1? In this case, this will translate into 0, 0, 0 plus 1. So you have to advance location by 1 and you will reach to the second location. So thus this will read the first location, this will read the second location, and you will be able to read 2 and so on. So what is exactly this 0 and 1? It depends on the what is the data type of the array, right? So let's say that you are trying to store a character A on the array. So to store a character, you need 8 bits, or we can also call it as a byte. You need 1 byte. Or let's say to store a number 1, if you want to store a number 1, you may need 2 bytes, right? So if your array is of type integer, if your array is of type integer, and if your array is of type character, this indexes do play a different role. So what is the role? Let's assume that you have a character array. Then what will happen is the base address 000 plus the index into the size of data type. Size of data type. Now the characters array, the size is 1, but 1 into 0 will result into 0, right? So what it means is that the array is of type character array, and from the base address, we call it as a base address, you need to read 1 byte or 8 bits to read first character completely. Now this scenario changes if you have an integer array. Let's say now you have an int array. Now let's assume that integer is of size 2 bytes. Focus here, integer is of size 2 bytes. So base address plus 0 into 2 bytes, where again the 0 and 2 results into 0, and again you start reading from the base address. But this time this integer data type plays a role that instead of reading 1 byte in the case of character, you will be reading 1 byte from the base address. In the case of integer, you will be reading 2 bytes from the base address. So this number 1 is stored into 2 bytes of the memory location. Now when you go to the second location, obviously 0, 0, 0 plus the index into 2 bytes. So what it translates like this. From the base address, you have to travel 2 bytes to get to the next element that you want to read. So what is the base address? Base address is 0, 0, 0. So you start reading the next element. Let's say you start reading the next element. So next element is starting at the address of 0th location. So let's say this is the start of the array. So you reached here. From there, the system is telling that you have to move to twice, two locations. So here it says that you have to move 2 bytes from the base address. Let's say byte 1. So you reach some intermediate address, and then again 1 byte, that is 2 byte. So when you travel 2 locations, 2 bytes, you will reach to the start of the second location. And this number again will be using 2 bytes for the storing of this number 2. So you will read this 2 bytes as in a single quantity. So that's how the data type plays a vital role in deciding how you read the array. To clear out the diagram, what I can say is, let's assume that we are using a character array. So if let me create a character array here immediately. 1. Okay, so inside this I will be storing A, B, and I'll be storing C. So this first location will be of 8 bits. The second location will be of again 8 bits. 8 bits will be used to store the second number. Again, the third will be of again 8 bits. So this each location is of 1 byte in size. Now assume that we are using an integer array now. Now in the case of integer array, let me create an integer array. Let's again assume that this integer array is of 3 locations. But there is a catch here. Now integer array, let's say each location is of 2 bytes, or each number is of 2 bytes, and we are storing 1, or we are storing 2, and then we are storing 3. But in reality, in the memory, we are using 2 bytes to store this 1. We are using 2 bytes to store this 2. We are using 2 bytes to store 3, right? And let's say this is the first address 0, 0, 0. This is the second address 0, 0, 1, 0, 0, 2, 0, 0, 3, 0, 0, 4, 0, 0, 5. So we are using 5 different addresses, and group of these first 2 addresses, this represents the first number, this represents the second number, and these 2 bytes represent the third number. So my base address of the array is 0, 0, 0. So how it translates, if I want to read the 2 bytes for the first number, then I should start at the index 0 and my index value into the number of bytes that I should travel to go to the next number. But as my index is 0, this results into 0. So 0 base address plus 0, you start reading at the base address only. So now, as this is an integer array, computer knows that from this base address, you must read 2 bytes. That is byte at the 000 as well as byte at the 001. And together these 2 bytes will form a single number, which is 1. Now this is how we are reading index 0 for the integer array. Now if we want to go to the second location, the formula is like this. So base address plus index into 2 bytes. Now, this is not going to translate it to 0. 1 into 2, let's say 2. So you have to travel 2 bytes. So where are 2 bytes from the base address? So base address is at 000. From here, 1 byte plus you reach to the 001. Again, you have traveled only 1 byte. You need to travel another byte to go to the start of the next address. So you again travel to the 1 more byte, and that is you are traveling 2 bytes and you reach to the start of the second location, that is 002. So you reached here now. But here again the array is of type int. That means you have to read 2 bytes to read this number completely. So you read from the 002, you have to read 2 bytes. So what are the 2 bytes? The 002 byte itself and the next byte, that is 003. So when you read these 002 and 003 bytes, you are reading the second index. Is the concept of the array clear? Or anyone have a doubt? If anyone have a doubt, please unmute yourself and ask, or else we will proceed with the program. Is the concept of indexing and the array clear? Anyone have a doubt? I shall repeat if anyone have a doubt. Okay, all thumbs up. Great. Repeat one. Sir. Please explain again. Okay. So guys, there are 2 requests for repeating the stuff. Can you please unmute Atul and Jatin? Please let me know what exactly I should explain, or I should explain the entire story again.
No, not
It is
not
only
the entire story, sir.
Who is this?
Sir, Jatin Sawant.
Jatin. So how much I should repeat?
Sir, how did you calculate that 003? How we should go to the 003 address? That
Okay.
only, sir.
Okay, fine. And who was,
Yeah.
okay, one more. Atul, how much I should repeat?
Sir, I have got the concept of array that you have explained, but I am unable to link it with the given program that we have done.
So that is the only thing you are worried about, like how it is getting linked to the program, right? So of course we are
Yes,
going to write it again. That's not an issue. So any issue in the concept? This concept is clear?
yes, sir. Concept is clear.
Great. So Jatin, now please explain me, tell me more about your doubt. You are not sure about how this thing will go to the 003,
Yes,
right?
sir. Yes, sir.
Yes. So let's say when we are reading integer, let me pull it down a bit. So here, when you are telling the computer that you are creating a character variable, character, let's say C, and when you store a character inside it, what computer knows is that computer is allocating 8 bits or 1 byte, which you can create a code, ASCII code or assembly code of this 8 bytes, which is representing C character. Let's for now assume that the C character is represented by some random code. So this is not an exact code, I am just assuming. Are we sure? So assume that this is the code for C. So now how this is how this 1 byte is used to represent C character in the memory. Now if I have to read when I say printf, and let's say %c and let's say C character, that time what computer knows that, okay, I need to read a character variable. So I have to read 1 byte from the computer, and it reads this 1 byte code. So this statement reads this 1 byte code and translates it into the character representation, and it prints C on the screen. Is it clear, Jatin? Okay, Jatin, thank you.
Yes, sir. It is.
Now next story is, let's say instead of creating an integer character variable, you are creating a integer I variable, and you stored 1 inside it. But to store an integer variable, computer uses 2 bytes. So 000, that is 1 byte, and you are again going to make use of another byte, 000. So now this location of 2 bytes together forms a one location for representing a int. Now this 2 bytes together, will be used to represent 1. Now to represent 1, the code may go like this. To represent 1 in the computer's memory, the code may go like this. 0 0 0 0 0 0 0 0 and 0 0 0 0 0 0 1. Again, this depends on big endian and little endian. You will learn about this more in your COA subject. Okay, so in the COA you will explore the concept of big endian and little endian. Right now I'll skip the part. I'll just say that this 2 bytes, in the first location there are all zeros, in the second location there are all zeros except the last digit is 1, and together this represents 1 in the system. Okay, now when you write a printf statement, percent d, and sorry, variable is I. So variable is I. Now what happens is when you write this printf statement, when earlier we were using C, now we are using D here. So this C tells the system that it's a character, you read 1 byte. This D informs the system that the I, you have to read 2 bytes. So what this translates into, read these 2 bytes from the system, convert it to the number and present it on the screen. That's why we read 2 bytes. So what will happen if you are storing this number in the array? Let's come back to the array. To store the first number, here, to store this first number, we are using location 000 and 001. So to read this number 1, you have to read 2 bytes. First byte, which is whose address is 000, and the second byte whose address is 001. So when you read 2 bytes from the system, you are actually reading one number. Now, what if you want to go to the second index? When you want to go to the second index, the formula is very clear. What is the formula? Base address plus the index into the size of data type. Now here the size of data type is 2, index is 1. So 1 into 2, it will translate into 2. Plus what? Base address. Let's say base address is 000. So what this statement means is that from the base address, you have to travel 2 bytes to reach to the first number. So how will travel the 2 bytes location? What is the start address? Start address is 000. So from here, when it travels 1 byte location, it reaches to the address 001. And from the 001, it has to travel second byte. So when it travels to the second byte, it reaches from 001 to 002. Now you are at the start address of the number 2. So as soon as you reach start address of the number 2, system knows that again you are dealing with the integer type of a variable. And to read an integer, your computer knows that I have to read 2 bytes to read a number completely. So my first byte is at the start address, present current address. What is my present current address when I've already reached 002? Sorry, where is the pointer? Okay. So my current present address is 002. So this 002 is my present address. And now I read 2 bytes, that is present byte, which is 002, and the next byte, which is 003. I together read the second number. So that's how I go to the third 003 location, because I need to read 2 bytes in turn to read a complete number. Are we clear, Jatin?
Yes, sir. Got it. Yes, sir. Thank you.
Okay, great. So any doubt in this? If we don't have any doubt, I'll switch to the program. Great. So let's quickly go back to the program and verify what we are talking. So before going back to the program, one simple question. Let me clear this paint and simple question. As I said, every variable have 3 aspects, right? So if I am creating, let's say if I created a variable integer I, if I say this is 3. So this variable have 3 aspects. One is its name label. This is the label. Then the value, this is the value, and its address. So every variable have 3 aspects: its label, its value, and its address. Similarly, if I create integer ARR of 2, so what it means, in the memory, you are going to create array of size 2. Right, so this is the ARR, and it will have 2 indexes, 0th index and first index. This ARR must be storing something because it's also a variable, and every variable have 3 aspects. What are these 3 aspects? Its label, its address, let's assume this address is 001 again, but what is the value of this ARR? So this value of the ARR is nothing but the start address of this memory location. So let's say this is the start address of the memory location. So this, when we are saying if you access this ARR printf percent, let's say D, and if you print ARR, only ARR, you will actually print the start address of the array. Okay. And if you print ARR of 0, then you will print the first number which is stored in the array. So starting from the 0th index, you will read 2 bytes, that is 001 and 002, and together these 2 bytes will print one number. So that is the index. And if you print without index, you will get the start address of the array. Okay. So let's verify these all things in the program. So I'll quickly go to the code blocks. Okay. So I have this program, and we know that this will print 1 on the screen. Okay, only this is what we are doing. This will print 1 on the screen. Yeah, okay. Now we have array. Let's create an array of size 2. Sorry, array of size 2. And in the first location, I'll be storing 1. And in the second location, I'll store 2. So now I have array wherein there are 2 locations. First location is initialized to 1. Second location is initialized to 2. Now we will call a function called as get data to, and we will pass ARR to the function. Let's write this function. Let's say that this function is returning void. Okay, there is a question in the chat window by Sakshi. Let me check the question before proceeding. Sakshi, can you please unmute yourself and ask me the doubt? I really didn't get it. Sakshi?
Hello, sir.
Yes.
Actually, you wrote in the previous slide as 0 and 1 only indices. So, when we want ARR of 2, then there should be 3 indices, na? 0, 1, and 2.
May I go to the diagram? Actually, I erased it. Let's see whether we can store. I really doubt that whether that is there or not. May I just draw the again? Or you have a doubt in the program or in the paint? So what you were saying was I created an array, right? Let me create an array. So here there is a index 0 and there is index 1 and there is index 2. Now can you please repeat your question?
No, sir, I was asking about only diagram. Means you wrote only 0 and 1 indices.
I didn't see. I am not exactly about the program or about the historical diagram.
No, means you first drew the diagram 0 and 1 means
So I created
indices,
like
and then you ask the question that if we write ARR of 2, then we will get the answer that is the value of ARR 2.
so there are three indices, no?
So
0,
there
1
are
and
three
2.
indices, no? 0 and
So if I
But
write
you
ARR
if I
didn't
write ARR
of 2, then I'll
of
get,
2,
let's say
then I'll
probably
get, let's say
there is 3.
probably
So I'll
there is
get this 3.
so I get this 3.
yes.
Okay.
Okay.
Any other doubt? Maybe. So now I have ARR of 2 of size 2, and now I have two indices, 0th index and the first index, and I'm storing 0 and 1 inside it. Now what I'm doing is I'm passing this array to the function called as getData. So what I can do is I will type void get underscore data 2 and integer. I'll say I'll give ARR. I'll use the same name. Okay, and I'm saying that the get data is accepting array as an argument, and inside this I'll say ARR of 0 is equal to 22. Fine. So there is no return statement, nothing. As soon as I come back to the main method, what I'll do is printf uh, output of get data to ARR is equal to %d comma ARR of course the first value which uh, we have accessed in the get data to function. Can you tell me can anyone guess what will be the output of this program for this particular ARR2 only? I am interested. What will be the output of this program for ARR of 0? Anyone? 1. So let's. Anyone else? I can see only 2 people are responding. Or many people have responded with 1. 22 is the answer by Mr. Samir is answering as 22. The most of the people are giving answer as 1. Any other answers? Only 6-7 students have replied as an or have given the answer. So I'm getting maybe 1. Anyone? Okay, there are 2 people who are answering as 22. One is Mr. Sami and there is Ms. Gayatri who have answered as 22, and Jatin is also now answering as 22. So Atul is also saying 22. Fine. Now many people are coming as 22 as an answer. Can you, Ms. Shraddha, can you tell me why the answer is 22? Why the answer is 22?
Void get data to in bracket int array. So it will so next get data to array will be take value as 22.
Can you please repeat it?
Get data to in void get data to. We have written that array of 0 is equal to 22. So it will
So that's right.
give as value as 22.
Okay, fine. So let me modify this program a bit. What I'll do is I'll call it as dr ARR. And here I will also modify DARR. Now what will be the output? Shraddha? Now what will be the output if I change the ARR to the DARR?
1.
1. Okay. Any other person? Jatin is saying 1. Pranav is also saying 1. Okay. Gayatri is still getting it as 22. So guys, let's run this program and see. Now I have DARR, right? And now if I run this, you can see we still have 22. It doesn't matter if whether I'm using ARR or DRR. Okay, so I've seen this answer many times. So I guess in the last session, we were supposed to understand this concept. See here, I was using I. Now if I replace this K with the I, and even if I increase the variable I in the get data. So what is this flow? This flow that says that you have a variable I in the main method. You have this variable I in the main method. You have the ARR variable in the main method initialized with some values, and then you call get data on the I. What we are doing in the get data, we are getting the value of I, we are returning the value of I plus 1, but we are not catching it anywhere in the main method. So return value will be lost. Or I can simply change this return type to void. If I'm not catching the returned value, I can simply change it to void. And here I will simply write I plus 1. I is equal to I plus 1. Now, this I variable, when you pass the variable I in the main method, that time we are passing the value. Right? So let me quickly open up a paint alongside the program to understand in a better style what is happening. What really happens is, pay attention. Okay. So what really happens is when we are calling get data and we are calling with variable I. So this line translates into get data and replace with the value of I. So every variable have three aspects. So this label I also have three aspects. That is its address, its value, and its label. So when we are using integer I variable, when we are calling I, when we are passing I, here get data copies the value of the variable I. So what is the value of variable I? 1. So where even if I am saying I, you are actually passing value of variable I, which is 1. So what happens inside the get data function? So when get data function, get data gets called, it sees that I is equal to passed value. So now this I is from get data. This I is from get data. This I is from get data here, new I. Now inside the get data, what we are doing is inside the get data, we are saying I is equal to I plus 1. So again, this new I is created and you say 1 plus 1, 2. So this new I have some new address. Let's say this is the new address. So look at the address of get data and look at the address of main method. Both addresses are completely different. So as both the addresses are completely different, the changes made inside get data gets lost when you come back to the main method. And in the main method, this line still prints 1. But in the case of ARR, whatever we have discussed a minute ago, what we have discussed, sorry. So what we have discussed a minute ago, what we discussed is when we create an array, say we have created an array, right? And this array will have two indexes, sorry, one. Now this array will have a start address. The start address is, let's say, 000 and 001, 002 and 003. So 3 locations inside the array, because it's an integer array and it will be storing values 1 and 2. So this ARR variable, array variable, when you create an array, this ARR stores 000. That is the first address of the array. So when you pass ARR, it replaces with the value. How we are calling get data to? We are saying get underscore data to, sorry, get underscore data to, that is a function, and in bracket we are saying ARR. So like the get data one function, get underscore data I, when we call I, the I is replaced with the value of I. So what is stored in I? I have three aspects: its label, its value, and its address. So what is stored inside I? I have stored 1. Similarly, this ARR variable also have three aspects. What are these three aspects of ARR variable? Its label, which is ARR, its address, and its value. So what is stored inside ARR is the start address of the array, 000. So when you call this function ARR with the ARR is replaced with the starting address of the array, 000. So what happens is, in the get data function, in the get data to function, when we are actually inside get data to function, get underscore data to, you are saying DARR here. You are saying DARR here. But what this DARR will do? This DARR is also a variable. So again, this variable will have three aspects: its label, its value, and its address. So this is some random address, and it's what is value? What is passed by the ARR? ARR has passed the base address of the array. So this will be copied inside the DARR. So now DARR also points to 000. So what is 000 for a computer? For computer, 000 means this memory which is the start address of the array. And inside this memory, what you are doing is, what you are saying in the program, in the function get data to, in the program function get data to, you are saying DARR of 0 is equal to 22. So what is DRR? What is the formula of we have just learned the formula, right? How these indexes are getting traveled. The base address plus index into size of data type. So what is base address? Base address is 000. What is index? Plus a, this is 0. So it knows that I have to go to the 000th address and store what? What store? Store 22. So this thing will all together come back here, and this 1 which is present in this memory is now replaced with 22. So when we come back to the main program, it says ARR of 0 is equal to 22. Are we clear with the concept, or shall I repeat? Anyone have a doubt? Great. Anyone have a doubt in this? Great, great.
Excuse me, sir.
Hmm. Yes.
In the void, void we have declared DRR and DARR, but we are printing ERR. Then why it is not saying error instead of printing 22?
Who is this?
It's Atul.
Atul. So in the main method, what is the name of the variable? Atul, are you there?
Yes, sir.
So what is the name of the variable in the main method?
ERR.
So that's why we are accessing ARR.
Yes, sir.
So
Okay, sir.
every variable in the scope of this opening curly bracket to closing bracket, whatever the variables are in here, those variables are in scope. In the get data, this DRR variable and whatever the variables between the opening and closing curly bracket of this get data to method, those variables are in scope. So as I am in the main method and I want to print the array, so I'm using the name used in the main method, ARR. Okay. Any other doubt? Call by value, call by reference. So guys, Gayatri, there is no reference in C. It's hard to understand what is the reference and what is the address. Eventually, you will learn what is the address in the what is the reference exactly in the C++. It's hard for me to show you the reference and address difference in the C. But actually, it is a call by value and call by address, not a reference. And there is a slight difference between what is the address and what is the reference. And you will definitely learn this in the C++. You will get this between the when your journey of C++ starts. Okay, but it's a quite correct answer. Thank you, Gayatri. Any other thing? Any other question? Okay, so let's continue. Let's continue. Now with this theory that we have just understood, like how the things are getting managed by the system, I'll write one program, and I'm sure that you people are aware that how do we access the address of this I variable. So let's learn that. So let me put a comment on most of the code. Okay. So I'll use this code whenever I want to utilize the earlier declared functions. So instead of that, what I'll do is I'll create something fresh. I'll say I have an integer k variable, which I'll initialize to 0. Now, or let's say initialize it to 1. And if I say printf percent %d, and if I take it as k, we all know that it will print 1 on the screen. Now, if I say printf %d, comma ampersand of k, let's see what it prints. Now, if I run this, okay, I should use 2 separate lines. That care should be taken /10. Otherwise, it will be hard to see. Now you can see that there is a number and there is a value. So this 1 is the value and this is the address. So this is a third one of the aspect of the variable k. So when we declared k in the program, okay, where it is, when we declared k in the program, this k have 3 aspects: its label, its value, and its address 56732. Okay, are you with me now, everyone? So how we access this? We access it using the label. So whenever I want to access the computer's memory whose address is 6356732, that time I do not access it as a number. So let's say if I ask you increment 6356732 by 1. So look how odd it will look if I ask you to increase the value of this address by 1. Instead of that, I'll ask you just do k plus plus or k plus 1. So now you understand better way what I'm asking. If I'm just saying k plus 1 instead of saying 65,000, 63,000, or what is that, 6,35,000, or not even that, 63,56,732 plus 1. So that is really odd, right? So that's why the address and the label and the value, of course. Now the next part, one more important part, let's replace this, or let's keep this k as it is, and let's add one more thing. Let's say integer ARR, and let's say I have 2 locations, and I'll simply initialize these 2 locations with some value. 0 is equal to 1, and ARR of 1 equal to 2. Now, if I say printf, if I say printf %d and of course ARR, look, let's leave, and sorry, it should be printf. And if I say printf %d comma ARR, sorry, I should access the value at the index. So let's run this. Okay, the program is still running. Close this. Run. So here you can see that, okay, I should use the /n and some values. I use here /n, and here let's say ARR of 0 is equal to, and here ARR is equal to %d. And now let's run one more time. Now you can see that the ARR of 0 is indicating the value 1. And what is the ARR? ARR is indicating the start address, 63,056, 724 something. Are you with me? So what is ARR? ARR is actually the first address of the array, starting address of the array. Okay. So great. Now there is a pointer variable in the C. The job of this variable is to store the address. Okay. So let's understand the concept of pointer. So what is a pointer? Like we have integer variable, or like we have a data variables. So what is the job of a variable? Variable is supposed to have three aspects. Variables always have three aspects. What is the aspect of a variable? It's memory. Yes, like this. Its name, maybe K, maybe I, maybe J, maybe L, whatever label you are using, and the computer assigned address. Now we are again assuming some basic simple address 000. So these are the labels. Maybe K is the label, I is the label, J is the label, or L is the label. One of the label you are using to access this memory, and this is the address. Similarly, pointer, and what is this? What this variable will store? If I, let's say, if I created integer K, then this K can store number. If I have created, let's say, character I, then this may store A or can store A. If I have, let's say, created some J with the float, then it can store some number. And let's say I have created L with some string variable or string value, then this L can store 2 characters at a time. Let's assume that. So depending on the data type, what you can store in this particular memory is defined, as well as what is the size of the memory is defined. So for example, if I'm using integer, this block will be of 2 bytes, right? We just discussed in the case of the array. If it is a character, it will be of 1 byte only. If it's a float, maybe 4 byte. If it's a string, depending on the number of characters inside a string. Likewise. So this block, how much memory can be allocated depends on what is the data type of the variable. In the case of the pointer, this phenomenon is seen. Like, even if you are using a pointer variable, you still have three aspects. That is actual memory value that you want to store, the base address of the pointer, and the label using which you can access this memory, right? But what is the job of a pointer variable? Pointer variables are special variables which are designed to keep address of other variable. Okay, so if I say integer I, I'll be creating a regular memory block like this. But if I say integer asterisk I, so what it means is that integer tells me that the memory block is of size 2 bytes. So whatever I'm reading, whatever I'm going to read will need to access 2 bytes. Star tells me that you are going to store an address, not a value. And this I is the label. So what is the effect of this? what is the effect of this call? The effect of this thing, effect of this line is computer reserves a memory, assign an address to this memory, and there is a variable called as I, which points to two things. If I access this as a star I or asterisk I, it will point to the value. And if I access it as a plain I, it will point to the address. In the normal variable, in the case of, let's say if I define integer k, then k, calling k will access the value. Calling k will access the value. And calling ampersand k will access the address. In the case of pointer, calling plain I accesses the address and calling star I accesses the value. So that is the difference. So if I give you, let's say, let me remove this all stuff. Let's say integer k is equal to 1. Now we know that how to access the address of the k and value of the k. Ampersand k, address of the k, only k, value of k. Now what if I have a variable p pointer, and let me not initialize this, right? And I'll also create an integer k which is initialized to 1. Now what is the job of this? Is a special variable, this is a pointer variable, and what kind of pointer it can store? It can point to a integer data. It can point to a integer data. So what integer data I have? I have k with me. So what I can do is I can say p is equal to k, but that's a problem. This statement is a problem. What I'm saying, I'm assigning the value of k to the p, but we know that what is stored inside a k if I assign this statement. So pointer variables are designed to store the address. But if I write like this, if this is my program, and if I'm saying p is equal to k, and if I have created k is equal to 1, and k also have address. So what is a pointer variable? Pointer variables are designed to store addresses. So we have here p, right? And the pointer variables are designed to store addresses. But if I say k, you are accessing a value. So that's the wrong thing. What you do is you have to access the address. So the correct statement shall be or should be ampersand of k. This returns the address. And now what is the effect of this? Effect of this statement is, let's say we have p with us. So what will happen if I say p is equal to ampersand of k? The effect is, as you have created a pointer variable, the pointer variable will have three aspects again. Its label, which is p, its value, and you are saying p is equal to ampersand of k, so it will copy 0, 0, 0, 0. And this also have its own address. Okay. And now if I access star p, it will access the value. And if I say, sorry, I should correct it a bit. Now if I say p, what is the value of p? If I'm accessing p, it will access the value of p. If I access p, it will access the value of p, like a regular variable. So what is the value of p? 0, 0, 0. If I want to access the address of p like a normal variable, what I can do is I can access ampersand of p. So this ampersand of p will result into the address of address, and the p results into the what is the value of a pointer variable. But as I said, accessing 0, 0, 0 doesn't make any sense. So this is a useless information for an end user. What we are interested in, what is value which is stored at this address, and we know that this is the address of a k, and at address 0, 0, 0 we are actually storing 1. So what does computer do is, if you access it as star p star, what it says is, sorry, I should say it as star p. If you access it as star p, that is a dereferencing. This is not a star or asterisk, it is called as a dereference operator. So if I use a dereference operator, it means that go to the address 0, 0, 0 and give me the value stored at this address. So it is like go to the address. if you go to the address 000, you are actually storing 1. So if I say printf, if I say printf %d and all that syntax, and if I say star p, the star p or the asterisk p means that go to the address and print the value. Go to the address and print the value. Go to the address and print the value. Whereas only p will print the address of the key, right? So let's try this program in programming. So I've said p ampersand k, that is the wrong thing. So I should store the address of k in the pointer. So now p is equal to k. Now printf %d k, that is the value of k. Printf, let's say k is equal to printf dereference pointer p, dereference the pointer p is equal to %d, and we will access pointer p in here. Printf, how we can print the address of k? I can say ampersand k is equal to %d, and here I'll say ampersand k. Should use /n to go to the next line in every printf statement, otherwise it will be a problem. Now printf %, so I will print only p is equal to %d, comma, we will just print p. Okay, now let's run this program. So here you can see that value of k and dereferencing the pointer, that is go to the address value of that particular address, both are pointing to 1. And you can see that the p and the ampersand k are pointing to the exact memory, 63,56,728, right? The pointer and the ampersand k are storing the same thing. So this is a pointer variable whose main purpose is to store the address. And if you want to access the value stored at the address, we use dereference operator, which is the asterisk symbol or a star symbol. If you want to use the pointer itself, you can directly call it as a pointer, plain pointer. It will print the value of it. So it's already 3:17. We will continue with this same discussion in the next session. You are free to join the next session. You can leave the meeting, no problem.